Well, I'm here with my new toy. I just got a Rigol DG4102, which is a function arbitrary waveform generator, and it covers sub-hertz to about 100 megahertz for sine waves, about 40, I think, for square waves, 40 megahertz. And it has modulation of various kinds: AM, FM, FSK, PSK, QPSK, 3 FSK, 4 FSK, which is some of you know as P25 modulation, etc., etc., etc. So a good addition to the ham shack, also to creating other kinds of signals that I need from time to time. So you see in front of you what the thing looks like. Channel 1 is set up right now for 1 kilohertz and 5 volts peak to peak, and no offset. And the phase is at 0, which is where I have it set. So there you go. We have that signal on the channel 1. And the same thing on channel 2, which you can see on the right side, the blue line. But it's not turned on at the moment. You can see the light is not on the channel 2 button. What I've got here, I have a BNC adapter for the scope probe for my oscilloscope, which is over there. And we'll look at that in a minute. Push that in here. Then we have a BNC which comes over to the spectrum analyzer, and it's on the right there. We'll look at that in a moment. First, let's put a reasonable frequency on here. I'm going to be working as IF frequencies for the moment, so we'll take a look at that. I'm going to put this thing at, it's a sine wave, it's channel 1, and what's highlighted is the 1 kilohertz, so we'll put in 10.7 megahertz, and that would be a typical IF frequency, or at least a common one. The amplitude's a little high, I think, here, so we'll punch that up and make it 0.224 volts RMS, or 224 millivolts RMS, which is about 0 dBm. Offset can be where it is, and phase can be where it is. We can transfer all of that by hitting this channel 1 equals channel 2 button to the second channel here, which is what's actually through this probe feeding the oscilloscope over there. So channel 2, and press that. Okay, got 10.7 to 224 millivolts. So it's going the same way as the other signal. Channel 1 I'll turn on here, and channel 2 I'll turn on, and I'll show you what channel 2 looks like. Very nice sine wave, and so there you go on that. And we'll go over to the spectrum analyzer, which is the Rigol DSA815-TG. And if you look here, you can carefully, in the 0 to 1500 meg span, you can see the 10.7 sticking up there, but it's hard to resolve. So let's change our stop frequency to 100 megahertz. Now you can see it's about 10.7. And if we hit the peak here, it'll say 10.833, but remember, our resolution for these markers is based on the screen. The screen's only 600 points across, so we're not going to get real good results when we have a sweep that's 100 megs wide. So I'm going to change that. First, I'm going to come up here and get the marker with the right arrow here and use marker to the center frequency. And that does two things. It changes the sweep. Start frequency is now 0 and it's going up to 21.666. If I punch up peak again, we should get a more accurate reading. 10.724, so we're within 24 kilohertz right now of the correct reading. But we also have a wide bandwidth here, so let's narrow the bandwidth. It's 300 kilohertz wide now, so let's go to, say, 10 kilohertz wide. Alright, now let's find that peak. That says 10.6888, so it's getting much closer. And the other thing is, with the trace here, we can go, sweep, I mean, hit the sweep here. We can go to the accuracy mode, and now it should read fairly accurately on that peak. And we can change our span to, say, 100 kilohertz, let's say. Span. 100 kilohertz. Now the problem we have here is that I goofed up. So let me go back span 20 megahertz. I got to get on the peak. Got to put it in the center frequency here first. Then I can do my span 100 kilohertz. And there we are. And then we can go bandwidth maybe 1 kilohertz. And now we can hit the peak. Gives us 10.699999. 10.6999 up here as well. So there you go. You're seeing the carrier itself. Seeing that its phase noise starts down here around minus 50 and goes down from there. Well, let's see what kind of trouble we can get into here by AM modulating this. It's set to AM at the moment. I've got several types that I can go to here. AM, FM, PM, ASK, FSK, PSK, BAPSK, QPSK, 3FSK, 4FSK, OSK, and PWM, although that doesn't seem to be highlighted. So anyway, let's go back to the other screen here. We'll hit AM. It's internal. It's 100 hertz. It's a sine wave. And it's 100% modulation depth, according to this. Again, we will make channel 1 go on channel 2, so we have the same sine wave modulated AM signal. It's 100 hertz, so it's probably beyond the resolution of our spectrum analyzer, but probably will work on, well, certainly will work on the scope. But we'll find out. Here goes the outputs. And we'll zip over here to the scope. Well, something's happening there, not sure what. Let's click this down. Looks like it's modulated with something. Okay, there it is. Ah, it's 1 kilohertz modulated with 100 hertz. That's why the thing doesn't look so solid there. That's because if I go back here to sine wave, we're at 1 kilohertz, not on 10.7, because I have turned this off and turned it back on. 10.7 megahertz. And then transfer it over to here. Alright. Oh, and we're overloading this guy. It's objecting over here. That's because our signal level is too high. So let's go into here and amplitude. We'll put in 20 dB of attenuation. Alright. So now let's quit arguing about it. But I think it's also because, we'll go back over here. Sorry, I overshot there. This is at 5 volts peak to peak. A little higher than we'd like to use. So again, we're on sine wave. We'll go down to amplitude here and make that 0.224. All right. Volts RMS, which is 224 millivolts RMS. Transfer that over to the other side here. So now they're both that way. Go back to the scope here. You'll see that we have much less signal than we had before. So we'll have to crank it up. And there we go. Nice clean AM signal, and it looks very good. Sorry it's jumping around. I can stop it here. I'm not certain why that scope does that. It doesn't seem to do well with RF signals with AM modulation. Yeah, what can I say? It's a cheap one. All right, so now we go back over to the spectrum analyzer here. And you can see that there is a carrier here, and it's going up and down because it's AM modulated. Let's hit the peak on here. It found the peak. It says it's at 10.00 megahertz, but we know that's probably not true because we have 600 points across here, and it's the closest point out of the 600 points from 0 to 1500 megahertz. So the step size is fairly sizable there. So let's go marker to center frequency here. All right. We'll hit the peak again and do marker to center frequency again. Put it right there. Now it says it's 10.733, so we're 33 kilohertz off. That's fairly decent, and that's out of 20 megahertz. If I take that now and take the span, which is 20 megahertz, and let's say go to 1 megahertz. 100 kilohertz. All right, peak, marker, center frequency. There we are. We're centered up. Sweeping pretty fast here. Not seeing any modulation on that because it's 100 hertz and it's beyond the scope's capability resolution wise, but let's see how good it is when we go to a bandwidth here of instead of 3 kilohertz received bandwidth, go to 100 hertz. It's going to slow it down considerably, of course. Yes, so now we need to widen that, so let's change the span here to, oh, I don't know, let's make it at 10 kilohertz on the span. Peak, marker, center frequency, there we go. Now you can sort of see that the side bands are there at 100 hertz. But as I said, it's beyond the resolution capability of this spectrum analyzer to look at 100 hertz. But in communications, generally speaking, we're talking about 300 hertz or something higher than that. So let's go to 300 hertz. And we'll just switch back over here to the DG4102. And I'll go to the modulation. And we'll go down to the AM frequency and make it 300 hertz. And transfer it over to the other side here. Come back here. Voila! We have no problem. So we have the 3 peaks with no problem whatsoever. And the other thing we could do here is go to marker function here. And wait a second here. Am I doing the right thing here? Oh, peak. Go to peak to the second screen here and go to peak table. And it should pick up all 3 of the peaks if I turn the table on. Well, it picks up more than just those peaks, actually. Picking up a lot of stuff down here. So what we may want to do for that is to change on peak here, change the search parameters peak excursion needs to be 10 dB out of the noise, and the peak threshold needs to be let's make it minus 50 dBm. All those small peaks down here are below 50, so we'll make that from minus 90 to 50 minus dBm. Now I got the three peaks. I have 10.70015, I have 10.6997, 10.700315. So I'm 300 kilohertz, 300 hertz plus and minus from the carrier there, which is what we'd expect to see. One thing to note about this is that the signal distortion is very low on this unit. We have, let's see, the peak is right here, so 10, 20, 30, 40, 50 dB down to these peaks. And these peaks are 50 dB down, and there's no other distortion shown on that, that particular waveform at 300 hertz. And I'm sure if I went to kilohertz, we'd have the same kind of pattern. Let's change this to kilohertz as a more typical tone that's used for modulation tests. We'll go over here. We'll punch up channel 1 here, and we are on the modulation frequency here, so let's make it 1 kilohertz. Swap that over to this channel, so it's now on both channels. And I'll switch this over to here. That's our old stored waveform. There it is again. So that's 1 kilohertz, as you can clearly see that it's higher in frequency. And once again, still 100% modulation and clean. Whoops, I think I bumped the thing there. And come over here, you can still see quite clearly the waveforms at 1 kilohertz. That's 10 kilohertz total sweep across here. So this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is sitting right on the 1 kilohertz. And it's also showing up here. 10.7, 10.9, 699, and 10.701. So we're very close to the frequency here. Certainly within the capability of the instrument, and probably both instruments, the spectrum analyzer and the generator there. And again, these are all down quite low by comparison. So here's your peak, or your carrier, I should say, 10, 20, 30, 40, 50 dB down. Let's change the modulation. Go back over here, and we'll go to type, and we'll put it on FM. Now we're doing an internal again. We need to go down and change this FM frequency to, it's down back at 100 hertz. Well, let's look at 100 hertz first. We'll also put it across over to here. So with 100 hertz, we are getting, and by the way, the deviation on that is set to 1 kilohertz. So this is a 100 hertz modulating tone with 1 kilohertz deviation, and it's about 2 kilohertz wide, looks like, which squares away with 1 kilohertz on 100 hertz being 10 to 1, and it's going plus 10 and minus 10 times 100, which is 1 kilohertz. All right, let's go over here and do a similar kind of thing. If we change our 100 to 1 kilohertz, there we go. We'll leave the deviation at 1 kilohertz pop it over to the other channel. Okay. And there we go. Now you can see how wide an FM signal gets when you're deviating 100 or 1 kilohertz deviation at 1 kilohertz modulating frequency. Yeah, these are down, and it goes down further, and it looks sort of like an AM signal, except that of course this is out of phase with that, whereas in an AM signal they'd be in phase, and obviously you're amplitude modulating. Okay, and let's up the modulation index. This is a modulation index of 1 kilohertz and 1 kilohertz deviation. So let's back off over to here again. Make this 3 kilohertz deviation on the deviation here. So we'll go to 3 kilohertz. Pop it over to the other side. Now we'll zip on over to the spectrum analyzer, and you'll see what they mean by wideband FM, or actually the old narrowband FM. That's what we used to call that, but it's now wideband FM, and narrowband FM is closer to what we just saw. Okay, so here we have 3 of these out here, and then it starts dropping off, and it's taking up more than that 10 kilohertz channel by the time it gets 20 dB below the peak. So that's where the advantage of FM is. You have extra energy in there, but it's spread over spectrum, so it's 6 of one and half a dozen of the other relative to the frequency spread versus the enhancement of the signal to noise ratio. And that's what some of the newer digital modes are trying to address. However, there are issues with those as well. At any rate, let's also look at the waveform over on the scope. Nope, that's not really it. I haven't reset this, so let's capture something again here. Okay, notice no amplitude change. And that's because there is no AM component. All we're doing is spreading the frequency around. And so FM in a Class C amplifier will go through quite nicely. Whereas AM or single sideband or double sideband, anything of a linear mode like that, will require a linear amplifier in order to maintain low distortion. Okay, let's take a look at another mode that's fairly common today with narrowband FM, and that's 4FSK, which was developed by Motorola. I believe it's the modulation technique used in P25 radios. And so let's look at channel 1 here, and we'll go to the type here. And I believe that's on the second page here. Yeah, 4FSK. All right, there's 4FSK. And let's transfer that over to here so we have it on both channels. And we're doing 100 hertz at the moment, so let's change that to 1 kilohertz. And we're doing a hop of 100 hertz now. I don't know what that should be. I should probably research that before I do this thing, but let's say that it's 1 kilohertz, just for grins. And now let's look at the spectrum on that. Again, before I do that, here's what it looks like carrier-wise, and obviously it's still got no AM component. Let's swing over to here to the spectrum, and as you see, like many digital modes. It's fairly broad. Little bit better on coming down that 20 dB here or so. But still it goes out fairly broadly. And you see several peaks here in this instance. 10.7000 being one of them. 10.701, etc. So that's the 4 FSK type arrangement. Now let's put span on 0. All right, so you'd seen what you would expect to see there. Let's also set the bandwidth to get that whole carrier. So let's say, I don't know, 10 kilohertz. And there you are. So it's doing the same thing there that you'd expect when all those different peaks are put together. It's still just a straight line. And there's no AM component, as you can see here. All right, well, I'm going to leave that for the moment. We'll do some more playing around with this thing later. I just thought that maybe you'd like to see the new piece of gear here in service and what it does.